Okay, we're moving on to the next definition, which is drywall frame. And in the hollow metal industry, there are two primary types of frames. There's other derivatives of frames, but in hollow metal, there's two types of frames. There's what we call masonry, and there's what we call drywall. And those two terms, don't get hung up on the term of what it's called. It's better to focus on just how they're different from each other, and then determining which one best suits your needs. Generally, you can use a masonry frame in many applications, and again, we're just calling it masonry. You can use it in lots of different wall constructions and anchoring types, so the type of wall it is and how you're going to fasten it to the wall. You can use that in most applications, but then there's one application where a drywall frame is really better suited for it. So when it comes to a client who needs a door and a frame, you then start this series of questions you go through this series of questions to arrive at the best frame for the application. And masonry frames work in most instances, but there's an application where the drywall frame is just simply best. And because we're focusing on a drywall frame definition, let's just talk about that. A drywall frame is best suited in every circumstance when you have a partition wall and the frame is going to go up or get installed after the wall is built. So partition wall means that you're doing some sort of an interior wall construction, almost always interior, where you're going to be employing wood studs or metal studs or a combination of drywall and plywood and plaster and soundboard and acoustic or RF or ballistic or lead lined material. Whatever the parts, pieces, the building materials that you're going to use to erect the wall, when that wall has been built and you've left an opening for the door to go into, meaning the door and the frame, a drywall frame is best suited for that. For primarily, well, for many reasons. I thought of two and then three and then a fourth reason. So let's just talk about what those reasons are right now. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. So in no particular order, a drywall frame is going to be best suited because its inherent design is such that you install the frame over the end of the wall after the wall is built. Meaning the way that it's been designed and engineered and manufactured as a frame is a three-piece type of construction, meaning the two jambs and the header, they're separate. When you take that frame to the opening, the door, the frame, and all the hardware, forgive me, to the opening to install it, you're going to be working with a knockdown, meaning the frame is not welded, it's in pieces. And that's generally three pieces. And the reason the drywall frame, and the word drywall is just what we put at the top of that piece of paper that we're going to fill with all of the reasons why a drywall frame is best suited. Inherent in a drywall frame, if someone says drywall frame, we're already thinking of certain things that are inherent. Knockdown. That's three-piece knockdown. It's not welded. Because you can't take a welded frame or an assembled frame and generally get that over the wall. Because you need to have the frame wrap over the end of the wall. And you can't wrap the wall, unless it's a split frame, you can't wrap the wall of an existing opening with a welded frame. So you use a knockdown drywall frame. And the application that always comes to mind is the frame going into the restroom of your typical coffee chain, your Dunkin' Donuts, your Starbucks. Lots of retail will have knockdown frames because they'll build that partition, they'll run the studs, they'll put the drywall, and then the door and frame will show up later. even though it would be preferable to have a welded frame, because in those same applications, notice, you ever walk into one of those bathrooms and the door hits the jamb? Sure, it's because the frame is no longer true plumb level and square, if it ever was. So inherent to a drywall frame is the fact that it doesn't stay true plumb level and square. That's important to know, because if you want a frame that's going to stay true plumb level and square, at least square, it's going to arrive to the job site welded. So inherent in a drywall frame is the fact that it's knockdown or three-piece. But inherent to a drywall frame is also the fact that it's really not the best option for it staying plumb, true, level, square, etc., because you're relying on its anchoring method, which we'll get into. So when you've got an existing opening, generally in an interior partition wall, you're going to use a drywall frame because it's three-piece knockdown. Also part of it is you have this is the wall. Generally the face of the wall is finished, except that it may not be painted. So there might be a final step of finishing not done to the wall, or maybe it is already painted. Inherent to the design of a drywall frame is what we call a back bend return. So here is a masonry frame. Typical is probably 4 3/4 jam depth masonry frame, and what I'm calling your attention to is this right here. That's called a return. Inherent in a drywall frame, which I have one right here, masonry frame, drywall frame. When I put them together, you can see the difference. The drywall frame has this back bend return. That is such that when you have the opening, here's our wall again, and you slide that over, the return of a masonry frame has a tendency to tear the face of the wall covering back. So you don't ever want to sell masonry frames to someone who's going to install them in a partition or a drywall type opening, because they're going to call you and tell you that the back of the frame ripped the paper of the drywall off. So you really, really want and need the back bend return, because that will prevent that from tearing back. So back bend returns are inherent in the design of drywall frames. Another, and again, in no particular order, an inherent design element of drywall frames is that they don't have dust boxes or mortar boxes or mortar guards over the hinge and hard strike and other hardware reinforcements. When you're doing a knockdown drywall, when you're doing a drywall frame, interior partition work, you don't necessarily need to have mortar guards over the back of your hinge plates, because you're not going to be sloshing mortar in the back of the jamb as you build the wall up. As you build the wall up, you're not going to be backfilling it with mortar. If you used a drywall frame in a masonry application where you were backfilling it with mortar, you are promptly going to fill all of those areas where you need to run screws in with concrete. Drywall frames don't have those dust guards because there's nothing in the wall that's going to prevent the screw from going into the back of the tapped reinforcements, which these little 6-inch samples don't have, obviously. There's no reason to have dust guards. And plus, the mortar, they're called mortar guards, dust boxes, mortar boxes, whatever. They're there to prevent the mortar from clogging and filling in the area where you've got drilled and tapped holes. And you don't have any function of that in a knockdown, I keep saying knockdown drywall. Those two concepts go together. A drywall frame means knockdown, but I'm always saying knockdown drywall frame. I'm not saying knockdown masonry frame, but it'd be more typical to say welded masonry frame, I suppose. Even though you can weld a drywall frame, I'm not exactly sure why you would weld a drywall frame, because you're really forcing this to work in other applications. So mortar boxes, dust boxes aren't part of drywall frames. That's inherent in the design. If you're going to need that, be mindful of the fact that you're not going to get that. And one other thing to think about as we're talking about mortar boxes or dust guards, dust boxes, is if you're doing a masonry frame and it's going to be filled with concrete, and you're going to need to come back later and drill the frame wherever for surface applied hardware, you'll generally take the header and weld reinforcement into it, wherever you need to have reinforcement, because you're going to drill and tap. You're going to drill and then tap. That piece of steel will be welded in there. And one thing that people will do is the installer, usually not the mason, because the mason's not the guy drilling and tapping later on, or just drilling. Someone who has to do that work is going to say, hey, I need a mortar box. Or what they'll do is they'll take a piece of 3/4 inch styrofoam insulation and just cut it with an X-Acto blade and then hold it in with masking tape, so that when they go to drill and tap, they're not hitting concrete. So that will create that little void behind there. So just since we're talking about mortar boxes. It's also possible that dust boxes or mortar guards can get in the way of your wall construction anyway. Be mindful you have to have a particular amount of penetration of the wall into the throat of the frame. NFPA 80 will call that out. So you need to be able to accomplish with getting the frame down and over. So a very common question when it comes to drywall frames is what rough opening size to leave. And generally 3/4 inch here, 3/4 inch here, and 3/4 inch here is generally perfect. I've not encountered a manufacturer who requires a different size than, so 3070 is going to be 37.5 by 84 3/4. 36 plus 3/4 plus 3/4, 37.5, 84 plus 3/4. Now, that rough opening is generally inherent to the concept of drywall frames. However, you'll notice this is an anchor. We're going to talk about that. This anchor is attached to the stop. In the soffit is where this screw is. That logic applies when you are working with a rabbeted frame like this. If you're working with a cased opening frame, you've just moved that anchor 5/8 closer on each side. So your rough opening really needs to be a different size for that sort of application. It needs to be a size that will accommodate your cased opening frame. And because you're moving that over, and that's generally 5/8, you're going to have a bigger rough opening to get that installed. But cased opening frames are fairly uncommon. So inherent in a drywall frame is needing to know the rough opening size. It's inherent to it. In that same 3070, if you've got a 2-inch face and a 2-inch face, the OD is 40 by 86. 40 by 86. Your rough opening, stud to stud, floor or whatever the sill is, to the underside of the rough header is going to be 84 3/4. You've got an 86-inch overall height. So a relationship between the door size and the size of the distance between the studs and the floor and the header is also inherent in a drywall frame. You need, that's something that goes with all of those. If someone's not asking for what rough opening size they should leave, you can count on sooner or later people calling and saying, yeah, what's wrong with your frame? What do you mean what's wrong with my frame? Well, I can see the underside of the stud from the header. And well, what rough opening did you leave? Well, I left, 39 by 86 1/4. And I say, that's not the size that is in the email. That stud's got to come down so the header can go up and over it. And that happens, and it's done, and it happens because the people doing the installation don't actually understand the product. And the first time they learn about it, then they understand it. But people move too quickly, too boldly, do they proceed with rough openings. And I tell them, and the next thing that they say is, do you know how much work that's going to be to add drywall? And I say, well, yeah, no, it's a lot of work actually. It's a hassle, in fact, to rough something out and not do it correctly. I've seen it. You got to add a stud, then you got to add drywall, and then you've got to tape all of that on both sides of the wall, sanded, the whole 9 yards. So getting that rough opening correct is really ideal. Don't make it too small, otherwise you're not going to get the frame down, because this is inherent in drywall frames. Another inherent characteristic is what we call a compression anchor. A compression anchor is a lot of fun. I have to grab a screwdriver. And you can add compression anchors to masonry frames if for some reason you felt like you needed to do that. I've had customers that have asked me to do that because they were going to literally take a masonry frame because they wanted the mortar guards or dust boxes, but they were going to put it in knockdown and wanted to have plumb anchors, or what these are called as well. They wanted to use these just to help get the frame plumb. Okay, I don't see any problem with that, but I also don't see that being a typical part of installation. I've had people that have asked me to put one up at the top and at the bottom of the jam because they were literally going to get it positioned perfectly vertical, plumb, and then screw it in or attach it, however, weld it, whatever they were going to do. Okay, I'm a fan of doing the work based on the approach that is most comfortable and most elegant to you. That's how I do projects as well. I very often do projects where I'm doing something for the first time, so it's new. But if that's what makes you comfortable, we can do that. We can give you those plumb anchors or compression anchors, however you like. Now, just take note of where this is located. Okay, there's a screw that's back here, and this compression anchor, this concept of compression or plumb anchor, is inherent to the term drywall frame. It's as inherent to it as the back bend return, and no mortar guards, and knockdown. As I take this and I turn it clockwise, lefty-loosey, righty-tighty, as I turn that clockwise, what you will notice is I'm throwing it out further. Okay? I'm throwing it out further. So what you'll want to do is make sure that the anchors counterclockwise on this frame are drawn in. You can see that I've drawn that all the way in. And this is part and parcel to how you install, I'm turning it clockwise now, this is how you install a drywall frame. So that compression anchor hits the stud, and then that forces it to move out, that forces the frame to move out this way. When you do that, what inherently happens, and these two frames aren't meant to go together because they're not notched, when you do that, it forces that miter to tighten up. The header goes up, the jam comes in, and as you move that compression anchor against the stud, the frame has nowhere to go but that way, and it locks and tightens up that miter. And you do that at the top of both sides of the jam to the point where you have a nice miter. Then you'll take the bottom of the legs, and all of this installation is inherent to drywall frames. You'll then take the bottom, I'm trying to keep this, you'll move that out so that you're true plumb, level, and square, and then in the face of the jam on each side at the bottom there's a dimple, and that's for a typical drywall screw that you're going to run through the drywall into the stud. And that's how you anchor drywall frames. And that approach of anchoring it is inherent with drywall frames. And we're going to show the typical installation steps for a knockdown drywall frame when we switch to the screen view. Drywall frames, because they're interior, generally don't have a need to be galvanized. They can possibly be a lighter gauge steel, but going lighter than 16 gauge is pretty atypical. Although you will see them in 18 gauge, you can see them in 18 gauge. And by that same token, it's extremely unusual to see them in thicker gauges. A thicker gauge like 14 gauge. It's very, I don't know that I've ever actually ordered a 14 gauge knockdown drywall frame. So 16 gauge, run-of-the-mill material. It's going to have a drywall frame. You'll notice that it's different than the masonry frame, drywall frame. You'll notice that it's got this gizmo here. These are nothing other than alignment tabs for the miter. That's going to force the header to align up nice with the face of this. And you'll always know a knockdown drywall frame when you see something that looks just like this flush screw and you see a miter. Well, masonry frames, when they're welded, you will almost never see the miter lines at the intersection of the header to the jams, because that the back side of the frame can be welded depending on the way that the welding has been specified. Sometimes you'll see, sometimes it will be a welded frame, but they only welded the back of the frame and left the miters exposed, which isn't ideal, just from an aesthetic perspective. And plus, I would think that it has a better ability to stay square when the face of that is welded. But generally, when you don't see that miter, you're going to know that someone just didn't put Bondo on there. That's been welded, ground, sanded, possibly Bondoed as well, depending on the quality of the welder, the quality of that job. Drywall frames can be prepped for all the different types of items that any other frame, masonry frame can be prepped for in terms of hardware, reinforced for material. When you're doing drywall frames, because of that back bend return, you're going to be limited as to what anchors you can use. You're not going to snap a T-anchor into this because that back bend return is literally in the way. So when you're doing drywall frames, you are pretty much generally going to see only compression anchors. Now, having said that, you could be doing welded masonry frames with some sort of a wood stud, metal stud, welded in stud anchor, and it could be on the job that they want back bend returns. And that's a great idea. I really think it is. You're going to want to think about the anchor that's being used to make sure the back bend return isn't in the way on a masonry frame. Probably welded, where you'll go through the back of the metal studs into the Z-flange that's welded to the throat of the frame. But having the back bend return allows the drywaller, so no studs are up. It's a big open space. Frame comes in and it's bolted to the floor, shot to the floor. Studs are brought up to everything, and then when the drywaller comes in, he wants to shoot the drywall in behind the frame. Yeah, they would like for that to slide in easier, and that back bend return will permit that sliding in easier. And plus also when they cut the drywall with a drywall saw, it's no longer 5/8 there. It's 5/8 further in the sheet, but it's not 5/8 out there because they've just ripped through it with a saw. So that flares out so it gets fatter, so they've got to jam it in. So you can have a back bend return on a masonry frame, and I think in those applications where you're doing interior work, the frames are going to be on site before any framing is done. Yeah, back bend returns with the right type of anchor would be a really good idea. Another facet of drywall frames is that they don't have floor anchors. I had mentioned earlier about the dimples. You're not going to have a welded in angle plate that you'll shoot down to the floor, just those dimples. So there's no concept of floor anchors. You can do floor anchors on these. You can do a reverse floor anchor as well if you wanted to get that jam in and then shoot it down because you knew you were going to put a threshold over it. Even in an interior application, you could do that. But at the end of the day, talking about the difference between a masonry frame and a drywall, and then focusing in on what a drywall frame is, I hope that you get the idea that whatever you want to do in terms of however you want the frame to come to you so as to be most conducive to your approach at installation can be done. And the reason how I've learned about all this is customers have said, "Hey, can you give me a reverse floor anchor?" And I say, "Yeah, I don't see why I can't. Why do you want that?" "Well, I got a big threshold and I want to screw it down to the floor." Okay, let's move to the screen view. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, drywall frame. A frame designed for installation in a wall constructed with studs and gypsum wallboard or other dry sheet facing material. Absolutely. You know, whatever you're doing, whatever the wall construction is, again, some sort of stud, or it could be partially masonry where you've got a 150-year-old, 125-year-old masonry building and you're going to put furring strips and drywall over it on both sides. And then you want to have a frame that's going to encapsulate the entire end of that wall, and it's going to be a 14-inch jam depth or a 13-inch wall thickness, whatever it is. That can be done. No problem at all. Whatever the wall is, they say constructed with studs and gypsum board because that's the 99% of all of it that you're really ever going to see. And that's just going to be stud, drywall, and then here comes your frame. Sorry, that's way out of scale. But there it is. It's going to encapsulate or cap the end of the wall. Meaning it's not going to do this. It's not going to butt to the end of the wall. It's going to come over and wrap over it. You get the concept. It's going to encapsulate, cap the end of the wall, cover it up. Let's take a look at those installation instructions I had mentioned for drywall frames because that's another inherent component to it. When I do a generic internet search for drywall frame installation instructions, I'm really looking for the Steel Door Institute, their link, because that's kind of what we're working on. How to install slip-on, that's another term that's used, they're slip-on, drywall frames with compression anchors probably. So they have a video here, and we're going to take a peek at that. Watch video, and then the printable manual. Let's watch the video first.
How to install slip-on drywall frames with compression anchors. In any building project, secure openings require the proper installation of a door frame. In this video, we'll demonstrate how to install slip-on drywall frames with compression anchors. Select the appropriate materials and tools for the project. Locate the correct frame by matching the opening number to the opening on the frame. Measure the width and height of the rough opening to ensure they meet the manufacturer's recommendations. Then measure the thickness of the wall for the frame throat opening. Be sure to check where the vertical studs meet the header. Slip the frame head over the rough opening header and center it in the opening. Install the hinge jamb by slipping it over the wall at an angle and engaging the jamb into the head. Finish straightening the jamb by slipping it over the wall, ensuring the drywall has...
Okay, I just wanted to pause it there for a moment and just to say, you know, if you show up to a job site with the basic tools and knockdown frames and doors and hinges and lock sets, you'll be able to hang an astounding number of these in a day. I had a job for a client, and the only day I could do the installation was on a Saturday, which actually worked out because no other trades were there on that day. And I think by lunchtime I had hung 7 complete openings, and I didn't get there till 8 o'clock. And I was done. And I even welded the miters in the field because the client asked me to do that. I says, well, the compression anchor is probably pretty good. He's like, well, if you can weld that, he says, it doesn't have to be a beautiful weld, but if you can weld it, I'd appreciate that. And I said, I can. I don't. It was a situation where the heat wasn't going to be a problem. There wasn't a fire. There weren't smoke detectors. There wasn't a fire alarm situation that I would trigger, and the heat wasn't a problem. I had a fire extinguisher with me, and I was able, basically I was just tack welding them is really what I was doing. But this approach that you're watching here is astounding because you will really tear through it. So let's move back to the video. We'll just go back a few seconds.
Engaging the jamb into the head. Finish straightening the jamb by slipping it over the wall, ensuring the drywall has entered the frame throat opening on both faces of the wall. Install the strike jamb the same way. Insert a setting spreader at the floor of the opening.
And you definitely don't want to get the frame twisted at all. You don't want there to be any twist such that it's like this, because that's going to really impact how well your opening works.
Make sure all 4 rabbets of the frame touch the spreader bar. This will prevent a twist in the frame. Snug the compression anchors evenly in each.
There is a tool that I want to show you. I'm going to get the part number. Okay, I had to grab that part number. Obviously, the 2x6 that the installer was using is great. Just Door Tools FS-set. What's nice about this, albeit they're not inexpensive, is they give you more than just what the client was able to do there. They allow you to margin the frame before drywall goes in if you're dealing with welded frames. But it's also going to be used for knockdown drywall frames in the sense that it will act as a spreader, but also they're telescoping. I think there's a single, there are 2 sizes, but when you buy the set, you'll get a single and then a double, one appropriate for. You're going to go. The single is 20 to 40 inch, 1'8" to 3'4", and then 3'6" to 6'0" wide openings. So that's a tool that's made for actually just doing that. Let's go back.
Snug the compression anchors evenly in each jamb.
Now, you can see that he's turning that clockwise. That's what's moving the jamb, making it tight up here and making it hopefully true plumb, level, and square.
Use a level
Checking.
and a framing square to check for plumb,
Yep.
square, and twist.
Yeah.
Anchor the base of the
Yep.
hinge jamb to both faces of the wall using the provided anchor system.
And then I'd be checking it
Repeat the
again.
process for the strike jamb and remove the spreader bar. Your frame installation is complete and is now ready for the next phase of construction.
What you see there, I want to back up.
Your frame installation is complete and is now ready for the next phase of construction.
What you see there is, I'm not sure if that's, hopefully that's blue masking tape. Never, never, never use a black magic marker on the hollow metal frame, because when they prime and paint, that will still bleed through. If you do it, you can expect the client to call and say that he had to sand all that off. And if you're going to mark the frames, do it with tape, or even better, do it in the throat, because tape can get pulled off unintentionally. Getting black magic marker out of the throat, that's going to be an intentional act. So you might want to mark all of your pieces if you're, if you want to make sure they're not installing. If you've got a lot of different sizes and it's all goofy, you're going to want to mark everything. Okay, now let's take a look at the actual instructions. Printable manual. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. How to install slip-on drywall frames with compression anchors. Okay, this is literally the steps from that video. In any building project, secure openings require the proper installation of a door frame. In this manual, we will demonstrate how to install slip-on drywall frames with compression anchors. Locate the correct frame by matching the opening number to the opening on the frame. Got it. I'm thinking that's tape. Okay, that's good. That's what they're showing. No problem with that. Measure the width and height of the rough opening to ensure that they meet the manufacturer's recommendations, meaning, do you have the right size hole? Don't proceed if you don't. Measure the thickness. Make sure you've got the right jamb depth. Check your frame. Make sure that all makes sense. Header always goes up first. It will just stay up there. It won't fall because the wall is indeed a bit flared out like that. Your stud, and then your second piece of drywall. I mean, grossly exaggerated, but that header will stay up there because it is fatter there, is the bottom line. Install the hinge jamb, hinge, strike jamb, whatever. I don't see a reason to start with the hinge jamb. That's just what they're telling you to do. Yeah, so the header and the jambs are always going to have some sort of alignment concept. Something will be inherent that will help align them together. Finish straightening the jamb by slipping it over the wall, ensuring the drywall has entered the frame throat opening on both faces of the wall. And you absolutely want to make sure that you have proper penetration. The drywall needs to go in, I think, a minimum of a ½ inch for compliance with NFPA 80. I'm quite sure it's ½ inch. I've just read it and forgotten that actual dimension countless times. Install the strike jamb the same way. Insert a setting spreader on the floor of the opening. Make sure all 4 rabbets of the frame touch the spreader bar. The spreader bar is this piece of wood that they created with this bird's mouth. This will prevent a twist in the frame. I think that's a great idea, and I would be leaving it there until you're done, which is what they show. You turn the compression anchors out, snug the compression anchors evenly in each jamb. Use a level and a framing square to check for plumb, twist, and square. Plumb, square, and twist. Anchor the base of the hinge jamb to both faces of the wall using the provided anchor system. Repeat the process for the strike jamb and remove the spreader bar when complete. These are guidelines only. Follow codes, standards, accepted practices in your area. So that's a really great available document there. And yeah, okay. So that covers up. Drywall profile, yeah, a lot of this same definition is going to apply to this. Let's move on to drywall profile. Thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.